Hey guys, I cannot wait for you to hear this conversation I just had with two dudes who are literally changing the game in epilepsy care. They are creating a device that will predict seizures before they happen. It's unbelievable. And I just can't wait for everyone to find out what Truman and Chris are up to with their company, Theta Neurotech. But before we dive into all that, I really want to give a huge shout out to community partners and sponsors for believing in this podcast. Neurelis, SK Life Science, Epilepsy Foundation of America, Danny Did Foundation, and Epilepsy Alliance America. You guys, you believe in this podcast and you make conversations like this possible. Okay, here we go. Well, Truman and Chris, thank you so much for being here. I have heard so much about you from other people in the epilepsy community, specifically in Chicago.
Yeah.
And they're like, when are you going to have Truman and Chris on? And I'm so happy you guys are here.
That's nice of them.
Yeah, thanks so much for having us.
Of course. Well, and the reason everyone's talking about you is because you're creating this game-changing epilepsy technology, which has the potential to predict a seizure before it happens, which is like the worst part of seizures is the unpredictability.
Mm-hmm.
And I just can't, like, as I say it, I can't even really believe it, even though I know we've talked about this before, and I can't wait for you to re-explain it to me because my brain has already forgotten it.
Yeah.
But let's start with like kind of the origin story, because right now you're creating an epilepsy device, but that's not where you guys started, right?
Yeah. Yeah. So the initial goal of the research we were doing is to create a consumer product, so like a Fitbit for the brain. So we weren't thinking about epilepsy at all in the beginning, actually. We were both athletes. I played college baseball at U Chicago.
Oh, cool.
And I wore the fitness trackers, Fitbit. I wore a Whoop specifically and used that.
I didn't even know that was a thing.
Yeah, it's like a Fitbit on
No, I
steroids
just,
a
all I
little
can hear
bit,
is
so.
whoop. There it is.
It's a good
No,
name,
okay,
yeah.
but I'm a millennial. I'm much older than you guys. Okay, keep going. Sorry.
No,
I'll
yeah.
stop interrupting with song lyrics.
No, yeah, Whoop. It's a good marketing name, but yeah, we wore those, and a lot of my teammates on the baseball team did too. So the goal was to create a Whoop, but for the brain, so a device that could monitor cognitive health, cognitive strain and recovery, and kind of provide that common consumer data back to that person. So that was the initial goal of the research, and it was a very winding path from there. But decided to focus on epilepsy after my cousin was diagnosed as a newborn, and it was kind of through that personal experience we decided to take the initial research and specifically target epileptic seizure prediction, which is where we're at today.
That's so nuts. So it's like, because I mean, it's just in the sense where it's like you go from the whole brain to then focusing on this little thing. What was that part? Not little thing. Epilepsy is not a little thing. But like, what was that? Where did that spark come from? Like, take me into that moment where you're like, actually, what if? Like, what did that look like?
Yeah.
Yeah, so there were a couple reasons. Like Truman was saying, we started off kind of thinking about the technology more broadly. And sort of as we were starting the company, we were also, both of us were still in college. We were going through, the little accelerator incubator programs that they have at these colleges that are there designed to help you essentially take, okay, I have the semblance of idea. What could be the actual business strategy that comes out of this? So through that process, we had to think pretty hard about, okay, who would our first customers be? How would they get access to the device? What would they be using it for? And so we spent a lot of time trying to essentially figure out what the pitch was. It felt like we had this really cool technology. There's a lot of potential, but we were sort of initially struggling with like, what like very actionable thing is this going to be able to do that's going to be able to drive essentially sales and the product usage sort of across the board. So within that, we sort of, like Truman was saying, we kind of toyed around with different ideas for a little bit. Initially, it was, a fitness common consumer thing. We sort of played around with the idea in our heads of using it specifically like in education, like being able to monitor like focus in education, be able to tailor lesson plans, things like that. Didn't necessarily love everything about that idea. And so we were kind of still searching. And then in one of our programs run by actually Vanderbilt was where we kind of grabbed onto the epilepsy idea. So for a couple different reasons, like if maybe the business case, which was that, we were trying to think about where EEG is being used currently. And obviously kind of the biggest space is within epilepsy.
Yes.
Pretty much everyone who has epilepsy knows what an EEG is or has had one done in the hospital before.
Right.
It's obviously very important in terms of being able to find locations of seizures or just even proof at all that it's epilepsy.
Totally. And this is where I have to say that, like, I hate EEGs. Like, I'm just gonna
Yeah.
be very honest. Like,
Right.
you're like, no
Yeah.
kidding, we've heard this before from everyone,
Yeah.
right? Because
Yeah.
like so many times they don't catch the seizure. Like, I've had
Right.
seizures in the EMU,
Yep.
and they were not caught. But thankfully, I had twice. I had one time a nurse and one time a resident that saw it,
Mm.
and they're like, "Oh no, you definitely had a seizure."
Yeah.
But there was like nothing caught. And so like I think that's why it would surprise a lot of my listeners to be like, wait, you have people who are doing EEG things on your podcast.
Yeah,
We've
yeah.
even got
Right.
the little EEG bear here, who's my new producer,
there you
Brave
go.
Bear, just to support. But like, tell us what this is that you are creating that is like it's based off off EEG, but not
Mhm.
crappy part of the EEG.
Yeah, exactly. We're trying to make a easy and comfortable to wear EEG system. So essentially what we've done, the goal of our work on the device side was to condense an EEG system, which bulky, lots of wires, gels everywhere, condense that down into something that can be applied on the skin like a sticker. So it's about the size of a paperclip, goes behind both ears on both sides, no wires, luckily, and monitors brain activity coming from just the temporal lobes of the brain, so on the right and left side. So it's the same principles of EEG. We're acquiring the same types of data. You can see the same spikes that occur during a seizure, but hopefully a lot easier to wear and maintain.
Yeah. I mean, when you say no wires, I'm like, what? Like that doesn't even,
Yeah.
register.
Yeah.
Bluetooth,
Yeah, there we go.
Bluetooth
it
Yeah.
helps. Yeah.
There you go.
Mhm.
Yeah,
So.
thank you. So what is it that it does? Because I know I was like, well, aren't there a lot of limitations? It sounds like a lot of limitations, you know, in catching seizures, but that's not even the purpose.
Yeah, right. So in our case, the goal is to predict a seizure, to detect shifts in brain activity that we found occur pretty consistently up to 2 hours prior to a seizure. So instead of with a full EEG, you have contacts all over the scalp and you're trying to identify specific spikes in specific areas of the brain. We've taken the approach of attempting to detect shifts in brain activity that we found occur across the two temporal lobes as a marker of a seizure about to happen. So not one that's actually happening, but one that's likely to happen in the next 2 hours. So positioning it here, and then we have a machine learning model that detects those shifts and hopefully alerts the patient of the impending seizure.
Okay, so for people like me who don't know what any of this means,
Yeah.
what does machine learning model do and what does that mean?
Yeah, it sounds a lot more complicated than it really is. So essentially, what we've done is we've taken data from it's been over 100 patients with epilepsy
Wow.
that was collected at UChicago Medicine, a couple of other hospitals, and we essentially took the data leading up to a seizure for those patients. There was over 100 seizures in those recordings, and we essentially taught this model to learn or know what types of patterns occur prior to a seizure. So it's like teaching a person to be very good at detecting changes in brain activity prior to a seizure. So we took that data, showed that model that data, and taught it to identify those patterns. And then the goal is that model can now identify those patterns for customers that are using the product in the future.
This data that like pre-seizure
Yeah.
brain activity. Did you ascertain that yourself, or has that been out there and I just didn't know, or
Yeah.
both?
It's been out there. So the data we used to train the model, the data coming from UChicago Medicine, this was collected from patients over the past 10 years, actually. So the data had been there. The work we've done is making advances in the model, so making the model as good as possible at detecting consistent shifts prior to a seizure. So the data's been there, but the techniques for learning what shifts are pre-seizure or not has been the advancement there.
Just going to say one of the other things about what we're doing that's maybe a little bit different than what's previously out there. You can find research papers on seizure prediction, seizure detection using, an in-hospital setup with the full EEG system like you were talking
Mhm.
about, electrodes pasted all around the scalp. But in order to be able to get that type of data, you would then, we're thinking about this from a continuous use perspective. So if someone's going to wear this in their day-to-day life type of data, someone would have to be hooked up to an EEG essentially all the time.
Yeah.
Right.
Yeah.
Or have some type of helmet or, headband or something that's giving a lot of sort of spatial coverage.
Mm-hmm.
We knew that wouldn't be, it's not good for a couple reasons. One is, like you mentioned, no one likes to wear that.
Yeah.
And two, even if you're okay, with it physically being on yourself, you don't want to be walking around, going to the grocery store, with an EEG headset on all the time. So that was kind of one of the important things from us in the beginning was how can we acquire this data using this technology, but in a way that's, pretty easy to use and non-stigmatizing for the user, because we don't want, people to be able to be identified as having epilepsy if they don't want to be,
Sure.
when they're just out doing their day-to-day life. So, what we have is we have the patches behind the ear, which is essentially you're looking at the same type of data, but you're just looking at a smaller section of the data. You're only getting information coming directly from, right in these locations as opposed to all over the head. So a lot of the work on the machine learning side has also been, this is something, there have been models that have been proven in the literature that seem to do really well, but can those models actually work when you limit the input data to just, EEG from both sides of the brain? And just that small sort of recording locations, essentially.
Yeah, and that is like one of my questions about limitations, like because
Yeah.
I know not everyone has seizures in their temporal lobes.
Right.
So
Right.
is this something that's, but a lot of people do, like myself. Like, is this something that's specifically for temporal lobe epilepsy?
It's a really good question. Question we're asking ourselves as well currently. So in our initial studies, we included all seizure types. So we didn't exclude any specific seizure types. And we had a small group of patients with focal frontal lobe seizures, for example, or generalized seizures. And we were effective in those initial studies in predicting shifts. It's a little unintuitive because you'd think, you have the contacts behind the ear, you're likely only going to capture temporal seizure activity, but we were effective. So that's a part of the next stage of our clinical validation is testing on different seizure types to see if we can, continue to predict those types of seizures. So it's a good question. We're figuring that out too.
Yeah,
So,
and you're like, we don't know. We're working on it.
yeah.
So tell me, like, when this comes to market,
Yeah.
what is it as of right now? What does it look like aside from the I don't know what you're calling them, panels behind your ears?
Little patches.
Patches, that's what it is. Yeah, little patches behind your ears, which you said is about the size of a paperclip.
Yeah.
And so, like, where does that data go? What happens with it? Is it something that's connected to a Fitbit, or what does that look like?
Yeah. So the patient applies the device behind both ears. It's paired with a mobile app. So on your phone or on a watch, the data is streamed over Bluetooth, no wires, to the mobile.
It's like
app.
the biggest selling point,
It is,
right?
yeah.
Yes.
Everyone hates wires.
Yeah.
But yeah, data is streamed over Bluetooth to a mobile app, and then when we predict a seizure, we alert the patient and their caretaker, anyone that's paired on the mobile app, of the impending seizure risk. The idea there is get out of a dangerous situation, get to safety, and maybe in the future treat the seizure based on that alert. So yeah.
How much warning do you get? I know George here, my seizure alert dog, gives me anywhere from 2 to 5 minutes.
Okay.
Is what he gets me. Gotcha. But what would you expect from this?
Yeah, we're definitely in the George range. Our average.
Can you just call it that
The George
from
range?
now on? Yeah, it's George range.
A little bit earlier, but in the same range. Our average was 36 minutes in an initial 27 patient study we did. That was the average. So the minimum was about 8 minutes. So that's closer to the George range, and then up to 2 hours in some cases.
Wow.
Yeah.
I mean, 36 minutes, I just think of that is so much time to go get to safety.
Right.
And I know just for me, and I've talked to other people too, if you take a rescue medication before a seizure, like when George alerts me, I take a rescue medication. Sometimes it stops the seizure or it makes it less intense.
Okay.
It has one of two effects,
Right.
And I know that's true for a lot of people with rescue medications. So I'm just thinking of how many seizures could be circumvented if you had 36 minutes notice.
Right.
That's incredible.
Yeah. Yeah. It's the goal is if we can alert early enough, take a fast acting medication and actually try to prevent it. So that is the goal. Yeah.
Hopefully allow the development of some more drugs in that space too. It's kind of hard to test a drug for how well it can prevent a seizure if we don't even have the technology to know they're coming right now, right? So
Oh my God.
sort of opens up the ability to do more testing and development kind of specifically in that space.
This is why I'm so glad you guys are doing this. I've never thought about that before. Like ever. I was just like, oh, it's just like the rest of epilepsy. It's trial and error. We're just going to throw some drugs at you and see what happens, you know?
Right.
Yeah. Hopefully we get, I mean, there's good rescue medications currently, but with predictive alerts that allows for the development of other ones.
Totally. Oh my God. Yeah. Or even just the modifications of those
tweaks.
too.
Yep.
Yeah. Oh my God. That's so incredible. This is something that we're hoping to see. And I don't want to ask you for a timeline. I feel like that could be stressful. But you know, it's something that I know I'm so excited about. I would wear those patches behind my ear tomorrow. You know, what are you guys thinking of, like, possibilities of getting this out there?
Yeah. So it's really going to depend. We have some conversations with the FDA plan to kind of discuss what our clinical validation looks like. But in the current state, we have 2 phases of clinical studies or trials that we're planning. So this first phase, which will launch soon. Happy to talk about that. But the goal of that study is just to see how well it's doing. So make changes to the device based on how it's performing.
So this study coming up will be to actually test it in hospital?
In real time. Yeah.
Yep.
Yeah.
Okay.
So yeah, the plan is to launch our first real-time study at UChicago Medicine here in the next couple of months.
Awesome.
Where we'll be transitioning from kind of this retrospective testing, the taking data and seeing how well we can predict seizures on pre-collected data. We'll actually be attempting to predict seizures in real time. So that study's coming up. If it goes well, we might be faster to market. If it doesn't go as well, then we'll have to make some improvements and things like that. But
sure.
I tell investors 2 to 2.5 years. That's the target to have a cleared product. So, but yeah.
But you know, like, I have to tell you, when there's not a lot of movement in this space, that is so hopeful as someone with epilepsy to hear that, to hear 2.5 years, or let's call it 5. I don't care.
Yeah.
Even if let's say it's 5, let's say it's 10. I'll take those goddamn patches, you know, if you just need like an outside test study, I'm happy to do that too.
I appreciate the patience with us on that. So,
well, I'm sure. But it's just like, we need this hope in this community. We need things to look forward to, even if they might not apply to us. Even if like let's say, you know, there's new pharmaceuticals, you know, being created all the time. And I know that it's not aimed towards my epilepsy, but it's like, who cares? That's something new for us, because it's such an under-researched and underdeveloped area, as I'm sure you guys, you're like, no shit, we have learned that on our own.
Yeah. I think we're maybe even more anxious than the patient, people with epilepsy that we've sort of talked to about it. They're, you know, we've had a lot of conversations with people over the years, and they're like, yeah, that's great. Just like, you know, let us know when it's out there, however long it takes you. And internally, you know, we're always stressing about timelines and trying to figure out ways to move faster. So I think it's a little bit flipped there.
Well, yeah, I know. I got an email this morning from Truman at 2 a.m. Yeah. So you guys are really grinding it. Like, there's...
I need to be scheduling my emails. I think I just send it in the morning or something, but yeah.
No, I appreciate the authenticity of it, you know, but you guys are really grinding, and appreciate that, you know. But yeah, know that this is a community that is, we have to be patient. Like, there's really no choice in that. So, so, okay, where can people like learn more about your technology? We haven't even named it yet.
We haven't. We haven't named it yet.
Right. So, but you guys have a company called Theta Neurotech, correct?
Correct.
Yes. Okay. So, where can people like go and visit the website to learn a little bit more?
Yeah. We have a website, thetaneurotech.com, just the name of the company. And then social media. There's social media linked on the website, Instagram and other things. We do have a wait list on the website that we like to patients that are inquiring about the tech, you know, point them there. So if you sign up there, we'll let you know. We'll obviously keep you posted on our progress, but let you know between, hopefully it's not 5 years, but in 2.5 years when it's cleared by the FDA or hopefully we actually, you know, can start providing it to patients. So that's the best way to to reach us. Yeah.
Okay.
Mhm.
And I'll make sure to drop those links in the episode
Appreciate that.
description so everyone. I mean, that's the thing too. I think people when they see waitlist, they don't know what that means,
Yeah.
right? Because especially for a lot of emerging tech. But it's like also like, oh, but these are also updates. Like this is,
Yes.
where you get to
Mhm.
find out how we're doing.
We want as much feedback as possible from the community too. That's a big part of the next step is we have this technology that we think, works relatively well. But it's a different story of if patients actually like it, what their opinion on how it feels behind their ear is, how they'd like to receive alerts. So we also plan to be doing a lot of outreach and involving the patient in the feedback process there. So.
That's something I didn't even think of because I was like, oh, slap the patches behind my ears.
Yeah.
But like, how long would they last? Like, can they get water on them or, like, do we have those answers yet? Or is that something you guys are still figuring out?
Yeah.
Some yes, some no.
Okay.
Yeah, like you say. So kind of in our ideal version of the device down the line, the device it's very easy to be applied like you were talking about. On the backside, likely we're going to have an adhesive so that the device can stick kind of right behind the ear that'd be able to last for a couple of days at a time. Our target wearing cycle right now, I would say, is probably 2 to 3 days at a time.
Okay.
But the sort of upkeep once that goes out is relatively small too. So it'd be, recharging the battery, which maybe would take you 20, 30 minutes, replacing the adhesive on the backside. It's essentially like a Band-Aid, right? You take it on, you put a new one, and then you put it back on your skin. So
totally.
That's kind of our goal there. Our goal would be to have it be water resistant / waterproof.
Sure.
So definitely aiming to be able to be worn in the shower or in rain, kind of like incidental water like that.
Yeah. Or maybe exercising and
Yeah,
stuff.
exercising with sweat, definitely.
Cool.
Some of the more intense, I guess, aspects like swimming. I don't know if we'll be able to get there. But it's certainly something that we'll look at.
We're not really supposed to swim anyway.
Okay.
So.
Yeah, exactly.
I mean, I'm not, because some people do, and I admire them, and I think it's amazing. So I don't want anyone thinking I'm shaming you for swimming. I just know it's something that, like, my doctor was like, unless you have someone like literally watching you, not a lifeguard, like so.
Yeah.
My husband's job now, Steve, just is my lifeguard. So.
Nice.
But
don't let our device be your de facto lifeguard, I think. So.
Yeah.
Yeah, that's another important thing.
Oh, I didn't even think of that.
Yeah, because this, if we have seizure prediction, we hope it's going to be, very highly accurate, and people are able to rely on it in their daily lives, make plans about, if they're going to work or going out with friends that night, based on that information. But we also, it's not going to be. It's not going to be 100% accurate in terms of giving you the correct risk of a seizure. And so we don't want people having a false sense of security too much, essentially.
It's just like one of those things that honestly, again, I'm just going to say gives me hope. It's something that I feel like I'm just like dreaming about when I hear about this. Like,
that's nice to hear.
Yeah.
I appreciate that.
Yeah.
Yeah.
Mm-hmm.
So your aunt and uncle, have they talked about, have you talked to them about this, or what's their response after?
Yeah.
And how is your nephew doing?
It's my niece,
Oh,
actually.
I'm sorry.
No, it's okay. No, so they were the inspiration, honestly. So we were originally doing the work and the consumer product, as I mentioned. And my cousin Noah, she was diagnosed as a newborn. So she had extremely severe case of epilepsy, was having multiple seizures per day, per night. She actually had a lobectomy, and she's been seizure free. So she's been great. That's been,
Wow.
I got to see her over Christmas, and she was doing awesome. So,
Aw.
but yeah, my cousins Andrew and Jess were the inspiration there, because Jess was doing probably the dream caretaker for a neurologist. She was building spreadsheets of when seizures were happening and all of the symptoms,
Amazing.
and she was telling me about them. And how useful it would have been to have an alert of when it might happen so she could pay specific attention. So, they were the inspiration, and for me, the original catalyst for focusing on epilepsy. But Noah's doing great now, which is good. So.
Oh, I love that.
Yeah.
Okay.
Yeah.
That's so cool. I know your face is lighting up as you're talking
No,
about
yeah.
Noah. That's so sweet.
Yeah, it was great.
That's awesome.
Mm-hmm.
And how did you guys even get started on this together? Like because did you guys didn't go to the same college, did you?
No, we went to different colleges. So Truman went to the University of Chicago. Myself, I went to Vanderbilt University down in Nashville. So No, the connection between us actually was a lot younger than college. So Truman and I are from the same hometown. I'm sure there's pictures floating around of us playing on the same travel ball baseball team when we were like 8 years old.
That's so cute.
So we've known each other for a very long time, went to the same
Wow.
elementary school, high school, and then, split for college. So
Mhm.
this was kind of the initial work on this company starting during college was kind of, a catalyst that was born out of that.
Yeah.
Yeah.
That's awesome. Oh my God, this story just gets more and more wholesome. Like I can't handle
Childhood
it.
friends right here.
Yeah.
Yeah, that's so wonderful.
Yeah.
So question for you, would you be open to, people who are listening, maybe throwing name ideas out at you guys?
That would be great. Actually.
Yeah?
Would be so great. Yeah.
Okay,
Yeah.
cool. Cause I mean, I don't have any off the top of my head, but like, I think this could be kind of fun to be like, what should we call these patches?
device,
you
yeah.
know? Yeah.
Yeah.
That would be great. Get the community gets to decide. That sounds fun.
Yeah. Okay.
We're not very good at that type of stuff. So
Yeah, we need some creative branding names.
Yeah.
That'd be great. It seems like a lot of the other like products and wearables in epilepsy, they all have like epi in the name.
Yeah.
So we kind of, I think, want to avoid that.
I
In
get
my
that.
opinion,
That's
just so
why-
it's easily identifiable. So if any viewers out there have any ideas, let us know.
Yeah, we'll put something out there for sure,
Be
just to
great.
get people like bring in ideas. We can have a vote. We'll do a whole like American Idol thing.
Yeah.
You know.
We can have a reveal show.
Yes,
Yeah.
totally. Well, you guys, thank you so much for being here.
Thank you.
And thank you for taking time out of your really crazy schedules to chat.
Thank you.
And I can't wait for everyone to hear about this. But before we close out, I'm going to ask you both 2 questions
Okay.
that have nothing to do with what we've been talking about.
Sounds
Sounds
good.
good.
Okay.
Yeah.
Number 1, what's your favorite color?
You want to go first?
Sure. Dark blue, like University of Kentucky blue.
Like the color you're wearing?
A little bit lighter than this, I guess.
Oh, okay. Got
More
it.
like a royal blue.
Okay.
I'm probably a red guy.
Yeah.
Not to wear, but the color red. I always liked it. So
Yeah, totally.
Gave me some extra time to think while you guys were talking.
There you
You're
go.
like, I haven't been asked this in 2nd grade.
haven't.
Why are we
Yeah.
doing this?
Yeah. It's nice.
None of our investors have asked us that question. I'm a little disappointed in them now.
Well,
Yeah,
now you
well.
can let them know. Yeah. Send you this clip. You can
I'm
put
sure
it.
that'll be important to them. Yeah.
Yeah. And then the second question is a little bit harder.
Hmm.
What does it mean to you to be a friend?
Yeah.
To be a friend?
Mm-hmm.
That's a good question.
Well, so me and Chris started as friends. To me, our relationship is both friendship and the company now. I think for us, or at least for me, being a friend is being able to oscillate between, different, conversation styles, or like being able to be personal and connect with someone on a personal level, but also be able to support them in their endeavors at the same time, and give tough love or tell the truth in specific instances. So I think being able to play, a number of different roles as a friend beyond just, what, a traditional friendship role is like. I think that's been important for me to
Yeah.
learn. And I think
I love that.
yeah.
I love that because it's just different layers, right?
yes,
Yeah.
the depth of the friendship goes beyond just kind of the surface level.
Yeah. Oh, I love that.
Yeah.
What about you, Chris?
Yeah, I was going to say, I think maybe a couple things. One is, I think, with your friends, you have to always try to make sure you're meeting them where they are. Sure notice is like, if you have friends in your daily life, sometimes they're at the top of the world, sometimes they're at the bottom, and just
Yeah.
knowing sort of, what you can do to help in those moments, I think is ultimately what it always comes down to. Because, if someone's riding high, there's no reason to try to necessarily pull them down all the
Right.
way. And if someone's down, there's no reason to like get hard on them if that's not what they need
Yeah.
in the moment. And so I think, especially, if you have friendships over time, you understand people's personality, you understand kind of like what they need, because you always want to be able to see them, at their full potential, the happiest, all of that stuff. But sort of what, advice you can give someone or what you can do to be there for them will obviously change depending on, where their mental state is at as well. So
Yeah.
I think just having an understanding of, where people are at, what they need, and being willing to, sometimes make sacrifices yourself to be able to provide that for them.
Totally.
Yeah.
Oh, that's really good. Your generation, I swear to God, you guys are so well-rounded. You have like such great perspectives. It sounds like you guys are therapists. Not like you've been in therapy, but like my generation's like, we need therapy. And you guys just are the therapists.
I think our generation needs it too. It seems like, but yeah.
Definitely. It was not a career path I've ever thought about, though, to be honest.
Yeah.
Well, I'm so glad you chose the career path you did. Thank you guys so much for everything you do, and thank you for coming on the podcast to talk about it.
Thank you for having us.
Absolutely.
Yeah, it was a great time, Lindis.
And we'll keep everyone posted.
Appreciate it.
Yeah.
Yeah.